Hi, my name is Gus and I work as a developer advocate on the Google AI team. Today, I'm going to teach you how to add machine learning to your developer toolbox. A brief summary of what we are going to learn here today is how to use turnkey solutions to empower you to use machine learning in your applications, no matter if you're a mobile, web, or backend developer, and without the need to learn all the advanced concepts that are usually associated with machine learning. I'll also tell you how to make the best use of these APIs to solve some more specific problems, and in the end, I'll go over a little bit on how to customize them for our own data. This is a XKCD cartoon from 2014, and it was a very good point at that time. From a developer point of view, using a GPS location is a common use case, and with that information, you can find where a picture was taken without too much work. But finding birds on a photo is a computer vision problem, and at that time, it was really hard to do it. 5 years, I would say they were correct. And more than that, computer vision is also a subfield of machine learning that's known to be very math-heavy. So starting with it comes with the need to learn linear algebra, calculus, statistics, and advanced computer science subjects. Well, that was true in 2014, for sure, but in 2022, that's not true anymore. The technology evolved a lot, and today is way easier to solve such problems. In 2015, Google open sourced TensorFlow. Before open sourcing, it was estimated that there were 300,000 AI practitioners globally. The open sourcing opened a whole new world of possibilities to developers, making it easier for us to start building machine learning applications. But it was still challenging because you needed to know the advanced math and also learn a new ecosystem of tools. Of course, the tools and frameworks around it evolved a lot after that, and today is much easier to build a machine learning model yourself than ever before. And it's estimated that there are close to 15 million data scientists worldwide, and from those, 3 to 4 million TensorFlow developers. Not only that, it got much easier to use machine learning without the need to build the model yourself. And this is what I'm going to show you today, a set of resources that will help you use state-of-the-art machine learning models on your applications the easy way. Let's take a look at this picture and try to solve the problem presented in XKCD cartoon. Check whether the photo is of a bird, and we will do the same task with APIs for mobile, web, and backend developers. So there's something for everyone. Let's go. Let's start with mobile developers. If you develop apps for Android or iOS, you can use machine learning and create magical experience for your users. Today, it's even hard to think about some apps without ML in them, like the camera app, for example. When you want to use machine learning on device, there are many details you have to keep in mind, like battery usage, local storage space, processor speed. Android and iOS mobile developers, different from big servers that can access on the cloud, mobile devices have limited resources, and you don't want to run heavy models and use all of the user device's resources. Making ML models suitable for on-device is not a trivial task. That's why having an easy API to help you is so important. This is where MLKit comes into play. MLKit is a mobile SDK that brings Google's on-device machine learning expertise to Android and iOS developers. The API is simple and gives you the basic to start using machine learning on your apps, and you don't need to know anything about machine learning or do any pre or post processing on the results. It abstracts away all the info required that you need to use on the input or the output. The APIs all run completely on device, allowing for real-time use cases where you want to process a live camera stream, for example. The SDK also comes with fine-tuned models designed and optimized for on-device execution. MLKit has many APIs for both vision and text to help you solve common problems like image labeling, object detection, OCR, barcode scanning, pose detection, translation, and many more. Many of these APIs were recently updated with new features and improvements, and again, all of it running completely on device with models optimized for running with restricted resources like a phone. Let's solve the bird recognition problem we mentioned earlier. Here is the code we could use. You load a bitmap, create a labeler, which is in a sense behind the curtains, just loading the model with the default options. Next step is running the inference on the image with the process method. It's important to note that you don't need to worry about any pre-processing of the image. For our bird image, I got a 98% confidence for the bird label, which is great. I also got 80% confidence that the image contains wings, which also makes sense. But what if I want to recognize which bird is it? For image classification and also for object detection API on MLKit, you can change the base model to be one more suitable for your problem. In our case, detecting birds. But how can I do that? Are there more specialized models available? If so, where will I get a model that recognizes birds? But before we go find these models, we need to understand a little bit better what we are looking for. Machine learning models are in a sense a set of transformations applied to an input that by the end gives you a value that you can interpret. For example, a picture has a bird in it. These set of transformations are called models. They are like a very long math equation. When you want to use these models on a mobile device, you have to have in mind that the hardware restrictions like memory, disk space, and processor power. To help you do that, TensorFlow has a specific SDK called TensorFlow Lite that allows you to run TensorFlow models on device. These models are converted to the TensorFlow Lite format, and when doing so, optimize it for on-device execution. Now we know what we want, a TensorFlow Lite model to recognize birds. Where can I find it? We have a place for finding machine learning models, TensorFlow Hub. On TensorFlow Hub, you can find thousands of TensorFlow models for you to use, with documentation and full sample code for you to try the model right on the browser if you want. There, you can find models for all kinds of tasks like image, text, and audio. As I mentioned before, running models on mobile devices require that the model is optimized to be smaller, faster, and less resource intensive. Doing these optimizations is not always trivial and takes some expertise. On TensorFlow Hub, you can find these optimized models published by experts and ready to be used with MLKit. Let's try searching for birds and filtering by TF-Lite models. Look, we are very lucky here. There is a model already converted to TensorFlow Lite that's specific for bird recognition. Now let's go back to that same code from earlier, but now loading the model from TensorFlow Hub. We also have to change the default options to use the downloaded model. With that, we'll get a 70% confidence that the picture contains a hummingbird, which is correct. I know the value is smaller than the previous 98% we had, but all the other returned possibilities have less than 4% confidence. That makes sense as the model knows it's a bird and birds have, of course, very similar characteristics. But among all of them, it's very certain that this is a hummingbird. And this is way more informative than just saying the picture contains a bird. So we managed to find out if there is a bird in the picture, which bird, without writing any line of machine learning code. How great is that? But what if you want to use custom text-related models? Or what if you want to use machine learning on audio? Or even some other image-related tasks like image segmentation? Or even if you want to use some models that are too new to be supported by MLKit? What can you do? You can use custom TensorFlow Lite models and write all the boilerplate code to integrate it in your app. Or you can just use the task library, which has a set of easy-to-use high-level APIs that hide the complexities of low-level code and reduce the need to write boilerplate code. This library is a set of easy-to-use task-specific APIs to help you use TensorFlow Lite models. The libraries also provide processing methods to help you convert your data to what a machine learning models would expect. ML models usually expect as input things like tensors. Tensors can be understood as arrays, and sometimes converting your data to tensors is tricky, error-prone, and without this specific knowledge is low. With Task Library, you get that for free, already optimized and ready to be extended in case you need something more custom. As of today, Task Library supports some core tasks like image classification and many others. And if you need a task that's not present yet, you can still use the processing methods to help you extend it for what you want. Okay, let's try something more advanced. We've seen how to know if there's a bird in an image, but what if you want to know if there's a bird singing in an audio file? The Task Library can help you with that. For example, here's the code to do the audio classification on Android. In summary, you get a buffer of audio from the microphone and do inference on it. But there's one thing missing here. When we create an audio classifier, we load a model, but where does this model come from? The Task Library has a more decoupled architecture, making it easier to extend and less dependent on specific models. It's exactly the same process we discussed before. Go to tfhub.dev, find a model for audio task, download, and use it. Same thing, and if you want to learn more about this task and many others, we have many tutorials to guide you. Just follow that link below. Okay, how about web developers? Creating web applications can be a challenging task with many things to consider. But luckily, web developers have a very rich ecosystem of tools and frameworks to help them with all kinds of tasks. And in the center, we have the JavaScript language used by over 70% of developers globally, that enables all great experience you have today on modern web applications. How can those developers also use machine learning? For them, we have TensorFlow.js that enables you to leverage the power of machine learning from your computer using JavaScript code. TensorFlow.js is Google's machine learning library for JavaScript, and it is just like the original version of TensorFlow, but it's aimed for folk who code in JavaScript or Node.js instead. This allows more developers to use machine learning without having to learn a new language, and use their creations in even more places than ever before, as JavaScript can run pretty much anywhere. There are some great benefits of running models on the browser, like lower latency, access to the device, lower costs, as fewer server-side resources need to keep running, zero install for frictionless and user experience, no complex environment setup. TensorFlow.js has already many models with an easy API for you to directly use in your web application. On the models page of the documentation, you can use and learn from many out-of-the-box solutions that you can use in just a few lines of code, like image classification, pose detection, text toxicity, face landmark detection, image segmentation, and more. These models can also be used on a Node.js server using the same libraries. Bonus feature: if you don't find the model you want in the TensorFlow.js models page, you can try finding one of TensorFlow Hub, or even convert Python-saved models to TensorFlow.js format using the command line converter. Let's solve the same problem using image classification, but on the browser now. First, we load the TensorFlow.js dependency. Then we load the MobileNet model. This is a common image classification model, very popular for being at the same time fast, small, and with good accuracy, optimized for mobile and client-side execution. Then we load the model to memory with the load method and call its classify method on an image. And you get predictions. Cool, right? But what if you need a model that's not converted to TensorFlow.js yet? No problem. You can use the TensorFlow Lite model. TensorFlow.js can also run TensorFlow Lite models in the browser too. Important details: TensorFlow Lite is more than a framework, but also a model format. So these models are optimized for mobile and will work great on the browser too. In the example image to the right, you can see more images converted to cartoon-like style using a TensorFlow Lite model directly in the browser. You can find this demo in the URL below, along with the documentation. This means that if you need a model that's converted to TensorFlow Lite format, you can use that in the browser. And if you need to find a new model for your application, you can do the same thing as the mobile developers and go to TensorFlow Hub and search for the models there. This enables all the research and work to convert models to TensorFlow Lite to also benefit JavaScript developers. Here is an example of using a TensorFlow Lite version of the BIRDS model in the browser with TensorFlow.js. The code is very similar as before, but you need some extra attention to details, like resizing the image, for example. This was taken care automatically for us in the previous example. As I said before, using a TensorFlow Lite model opens up to a lot of mobile-friendly models that are smaller and fast to download. And the same way with mobile developers, these executions are run completely on the client side. But what if you are a backend developer? Which tools can help you? If you're a backend developer, you are more used to use cloud services, containers, probably used to process large amounts of data and face different challenges than your friends from mobile and web world. Your job is usually building the backbone of applications, always having in mind scalability and performance. Given these characteristics, you can access more powerful APIs and models to provide even higher quality for your applications. The easiest way to have access to machine learning for backend developers is using Google Cloud ML APIs. You can make REST or RPC calls and have very detailed results for your queries with way more information than what you get from the solutions I've shown before. There are a couple of them. Cloud Vision for image-related tasks, natural language for text-related. There's one for video analysis, There's the popular translation one to convert text to speech, one to convert speech to text, and there's also one to understand healthcare-related text. For example, the Cloud Vision API, when shown the bird image we used before, gives us some good results. The API already recognized that there is a hummingbird in the image. This API can also be called in batches, making the process of analyzing big amounts of data faster. The same endpoint does also object detection, OCR, color analysis, and gives us some info into safe search scores. It's a very complete API. You can try directly on the link below with your own image just to have an idea. But what if you don't want to use these APIs, or you want to use machine learning on your private cloud or infrastructure? For these situations, you can use TensorFlow Serving. TensorFlow Serving is a flexible, high-performance serving system designed for production environments, providing clients with version access and out-of-the-box integration with TensorFlow modules. For example, you can serve multiple versions of the same module simultaneously, you can do A/B testing of experimental modules, it can support REST and gRPC, and it also supports GPUs. TF Serving also seamlessly works with Docker and Kubernetes to scale with demand. Let's see an example. You can use TensorFlow Serving from a Docker image, and don't worry about installing anything else. Just download the proper image and run the server from the command line. To start serving a model is just one line. To run the inference, you can make a REST call using the curl, for example, or with any other method you would prefer. Here, the example is using a simple model that gets the input, divides by 2, and adds 2, but you can use any TensorFlow module you'd like. For example, you could download the module from TensorFlow Hub and use it instead, like the birds one we tested earlier. Let's not forget that if you are a JavaScript developer, as we mentioned before, you can serve a model using Node.js instance using the same TensorFlow.js API we mentioned. Okay, by now you know some tools to help you use machine learning on your application. You know where to find models if needed, but there's one last step. What should you do when there's no available model that can solve your problem? Sometimes you are solving a problem that's similar to what is already solved, but not exactly. For example, let's suppose you want to find if an image has a specific toy, not only if there's a toy or not. Is it now the moment to learn linear algebra? Not yet. For this specific problem, you can customize a model that does image classification and make it specific for your toy's images. The idea is that an image classification model can look into an image and extract its features, contours, and colors. And if you can reteach this model to understand new concepts, you can customize it for your data. Let's see two tools that can help you do that. The first one is a Google Cloud one. AutoML enables you to train high-quality models specific for your needs. It uses some of the most advanced technologies for model creation to really get the best results possible, given your data. You can train models for vision, video intelligence, translation, natural language, and tables to use with structured data like database table. The generated model can be deployed on Google Cloud, and you can use it via REST API, similar to the previous Google Cloud APIs I mentioned earlier, but now with a model completely customized to your data. For the toys challenge that I mentioned earlier, all you need now is a dataset with annotated image and you're good to go. Another aspect is that the models generated by AutoML Vision can also be exported to TensorFlow Lite or TensorFlow.js formats, enabling you to use on your mobile or web application with the tools I mentioned earlier. If you don't want to use Google AutoML for some reason, I've got you covered. You can use TensorFlow Model Maker. TensorFlow Model Maker library simplifies the process of training a TensorFlow model using a custom dataset. It uses transfer learning to reduce the amount of training data required and shorten the training time. Transfer learning is a machine learning technique that reuses what a models know and specializes it to similar dataset. In our case, using a model that understands images but specializes it to be good at classifying toys. Model Maker can customize models for image classification, object detection, text classification, bird question answer, audio classification, and even recommendation. Let's take a look at some code. Here, we have a simple example of customizing an image classification model to classify flowers. As you can see, not many lines of code. You may not be used to Python code, but it's very easy, and we're doing the work to make the API as streamlined as possible, to make it easy to understand and to use. On the first 2 lines, we import the dependencies. Next, we load the flowers dataset, which is a popular dataset with 5 types of flowers. On the 5th line, we create a model with the create method. At this point, the model will be trained. This is usually where the process takes more time. After that, we evaluate the model, or in other words, try it with some data to see if the quality is good. And then we export it. Model Maker can export a model to regular TensorFlow, or TensorFlow Lite, or TensorFlow JS, and you can use it with all the previous APIs we talked about earlier. In this talk, I showed you some resources to help you use machine learning on your application. If you're a mobile developer, you can rely on MLKit or TensorFlow Task Library. If you are a web developer, you can use the TensorFlow.js framework, or that can also use TensorFlow Lite modules if you need. Backend developers can go for Google Cloud ML APIs, for powerful REST APIs, or they can create their own endpoint with TensorFlow Serving. All of this without the need to learn very advanced math or computer science topics. If the models are available are not enough, you can find more suitable ones on TensorFlow Hub. And if you want to customize the model for your own data, you can use Google AutoML or Model Maker to do that. If you want to learn more about specific subjects, there are some more resources to help you, like these sessions below, the workshop, and also this learning path that you can see on the link below. You can continue the conversation with me and the rest of the TensorFlow community in the TensorFlow forum. It's a place for our developers and contributors to engage with each other and the TensorFlow team. Head to discuss.tensorflow.org and create your account today. Thanks for your time, and don't forget to share with us what you build. Tag TensorFlow in your social media posts about your demos and bring the machine learning magic to our users. Thank you.